Alright, welcome to day 21. Grind don't stop. Started a little late today, but still gotta get it done. So let's get into it. Let's see how long this pointer course is. It's a bit hefty. Try to finish it, but should maybe under. If I could do it under 30, but I doubt it. But we'll see. Just gotta do it now. What the hell happened here? Oops. Oh Lord. Let's. Oh, I see. Hold on. There you go. So let's add this here. Gotta recopy paste this. Package main. Oops. Package main. Okay. And then. Wait. This is the. Oh my god. Damn it, take the main test. Pointers. I know some C++ pointers. Pointer is a variable that stores the memory address.
It is super critical to understand how pointers work. If you don't, it will lead to slow code or even incorrect code that's really hard to debug. So let's talk about what they are, how they work, and how to use them in the Go programming language. In order to understand pointers, we need to talk a little bit about RAM, or memory, right? Random access memory, which is basically the part of the hardware in our computer that stores data, right? Because pointers and variables are all about kind of how we store data in the memory of our computer. Let's start with something simple. Let's create a new variable in our program, and let's call it x. And we'll set x equal to 5. Under the hood, what happens automatically when we create a new variable and set it equal to 5 is somewhere in our computer's memory that variable's value is going to get stored. So let's say, for the sake of the example, that it's stored here in memory address 169. Now, memory in your computer, you can think of it as fairly simply a memory address that stores a value. So we've got kind of, millions of different memory addresses in which we can store data, and somewhere in memory, that value needs to live. So let's just say it gets assigned, again, automatically to address 169. Great. Now, what happens if I create a new variable, let's call it y, and set it equal to the current value of x? Y actually gets a new copy of the value. So x lives here at address 169. Y, let's just say, is going to live at address 170, and we get a copy of that 5. So down here in this table, this is where we're going to keep track of all of our variables. We'll say that x, so x is the variable name, lives at address 169, and it stores the value 5. Now y lives at address 170 and stores also the value 5. At its most basic, a pointer is just a variable that stores a memory address. So let's say, for example, that we create a new variable called z, and we set it to point, which uses the ampersand. I can't draw an ampersand. Pretend that that's an ampersand. A reference to x, right? It points to x. What that does is that we're creating a new variable called z. It's going to get a new address. Anytime we create a new variable, it's going to live in a new address in memory. Let's say it lives at address 171. But its value, instead of being 5, instead of being a copy of x, because we used kind of the pointer syntax or the reference syntax, the value is going to be the address of X. So we're going to store 169, which is the address of X, as the value. And Z is going to be a pointer type. So kind of the way the Go programming language works is it knows that Z is effectively pointing to the value 5, right? Because its address is 171, which stores a pointer to 169. So we can look up the value 5 at address 169. So what this means is if we update the value that Z points to, under the hood, we're updating X. So we can do things like pass pointers into functions, change the underlying value, and the value outside of that function is also changed, which again, in a language like Go doesn't happen normally, because typically if you pass a variable like X into a function and then change it, those changes are not seen outside of the function. You would need to return the updated value and then assign it into a new variable. So pointers basically allow us to change the value of something from within a function, right? From within a different scope. Let me show you what that looks like in a quick example. So remember that Z stores the value 169, which points to this address, which stores the value 5. So if we want to update the value of X without having access to the original variable X, what we can do is use the dereference operator, which is an asterisk. We can dereference Z. Now this dereference operator essentially follows this chain and finds the value, right? And we reassign into it, let's say the value 6. So this becomes 6, and this location in memory is updated now to hold the value 6. So we've updated the value of X without even using, right, the name X.
Isn't this to dereference? Okay, what is the issue right now? So I need to... It's using an ampersand, which means it's using the address. So just get rid of that. And then... Okay, what happens like this? This is just... Oh. Wait, what? So what is this saying? Fix the bug. Let's return a nice form. Okay, I guess don't take the address. This is just taking the address. Taking that. Well, yeah. Okay, I guess I pass. References. Okay, empty pointer. Its zero value is a nil, which means it doesn't point to any memory address. Empty pointers are called nil pointers. Instead of starting with a nil pointer, it's common to use the ampersand operator to get a pointer to its operand. KKK. Just an address, yeah. The star operator dereferences a pointer to get the original value. Okay. Unlike C, Go has no pointer arithmetic. That is super nice in C. But we'll see. So yeah, this is a pointer, right? This message is pointing to a string, right? Complete the remove profanity function. It should use the strings that replace all function. Read the docs on this. S old new. Okay. Oh no, that's not what I said. Replace all. Yeah. Example usage. The original string, old, and the new. So it's gonna be moo 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 moo. Okay, let's do that. It should just update the pointer. Okay. So I basically just need to do star message. Or is it, do I reassign? Yeah, okay, star message and do strings that replace all the message. Dereference, because we want the original message. And fub with, what is that? And then, oops. Whoa, 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 whoa. Fub shiz which and that's it. Okay. So it's side effect based. Okay, what happened? I'm not understanding what. Don't alter the function. Yeah, it's fine. Is a pointer. Like, I want the actual string. Right? Like, what does it say? Undefined message. Okay. Wait. Hold on, let me redo this. Oh my god. 3 failed? Oh, load. Oh. Oh, I see. Fub is 4 stars. Shiz is 4 stars, and which is 5 stars. Yeah. Beautiful. Lesson 3. Pass by reference. Yeah. Pass by reference is very useful, as you don't have to like if we're building something that like is like a list, right? Like I had this like experience with building like a big integer class in C++, and like one thing was to pass in to initiate like a big int per se. You can use a string data type, and it would be ridiculous to pass in a big string and copy it, as the purpose of like having the big int was to like not be like very like necessarily slow. So like we just pass the reference to that string, and it just makes it a lot easier, so we don't have to duplicate like, you know, stuff like that, which is a really good, you know, I like that. I really enjoyed that class. So I need to do what? I build a class. So functions in Go generally pass variables by bounding, meaning that the function is a copy of the most non-composite types. So we just increment it the same. It's the same, yeah. The main function still prints 5 because the increment is a copy of x. One of the most common use cases for pointers is to pass reference by variables by reference, meaning that the function receives the address of the original variable, not a copy of the value. This allows the function to update the original variable's value. It's like a very side effect stuff, you know. Fields of pointer. Very anti-pattern of, you know, Haskell per se, because no side effects in, you know, functional programming, pure functional programming. So even though Go is a very functions are first class, it's not necessarily, I don't know if it's necessarily definitely not functional language. So that's just something I'll point out. Anyways, field of pointers. When your function receives a pointer to a struct, you might try to access a field like this and encounter an error. A pointer to a struct. Instead, access it like you would normally do, using selector expression. This approach is recommended and the simplest way to access write a get message text function. Okay, so func get message text. Wait, this is how you make functions, right? Yeah. It should accept an analytics struct. So A for analytics. A pointer, so a pointer, and a message struct to a non-pointer. A message. So this is a message struct, and this is not a get message text. Increment the message total. The success fields of the message struct, and increment, and based on that increment the message total. Oh, I see. So these are pointers, so I don't have to, for specific structs, I don't have to, there's like the selector expression. So like, increment it. Yeah, so. So message total, we can access. And a dot message total message failed, message succeeded, so I could just access it normally. So if m dot success message failed succeeded plus plus else message failed plus plus and message total plus plus. All right, let's see that. Go test V. Did I copy this right? Oh yeah, I did. Oh wait. If m dot success is equal to true, how much am I supposed to increment? It should look at the success fields of the message structure and based on that increment the message totals. I don't get it. You should take out the success field of the message struct. Based on that, increment the message total, message succeeded, or message fields of the analytics. Okay, I did that. So if it's true, then do I gotta be true? I don't know if. Wait, so this is failed, total, succeeded, failed, total. What am I not understanding? Let's really see what's going on here. Expected is 1. Actual is... Oh, am I just getting 0, 0, 0? 0, 1, 0, 0. Getting completely different. Wait. Get message text. It should accept a pointer to analytics struct and a message struct, not a pointer. A message is not a pointer. So just made a copy. I don't know what I'm doing wrong. Message total, message failed. If it's true, then we succeed to increment that. If it's just, and the total is just, we just increment no matter what, right? Wait, if it's failed, then don't add it, maybe? Okay. What am I missing? A for analytics, right? Exactly. Do I gotta dereference it like this? That makes no difference. Okay, let me see what I'm not understanding. Recipient success is true, so I should increment 1. Wait. Yeah. Oh. So it's not. Huh. It's not reflecting. It's not reflecting. It's not reflecting it. Okay. Wait, what am I doing differently? Might receive a pointer to a struct. Okay, wait. What is wrong with this way? Huh. Am I supposed to return anything? No, right? Oh, it's not changing it. Oh. Like, maybe like this? Wait, what? I'm so confused. Wait. So it's right now I'm not getting anything changing. Like it's not changing my answers. Yeah, so I'm just literally just changing nothing. Okay, maybe I'm not missing. What is the difference? Analytics.message. It's literally just how you normally would. This approach is the recommended simplest way to access struct fields in Go, and it's a shorthand for this. So we see the pointing to analytics struct and a message struct, not a pointer. We should look at the success field in message and struct. Based on that, increment the message total or message fields in the appropriate. Yeah. If true, increment succeeded, but I guess I'm not. What? I guess I'm not like accessing the actual thing or something. Like, what? Ampersand? Yeah, it's taking the value that... Okay, hold on. What am I missing here? I'm stuck on this for some reason. It's just like, it's not changing the value. Instead, access is like you would normally do. What is this selector struct? It must be the blank identifier. The type of the selector expression is the type of f. If x is a package name, see the... Okay, for the following, for a value x of type t or pointer t, where t is not a pointer or interface type, x, f denotes the field or method at the shallowest depth of t where there is such an f. If there is not exactly one f with shallowest depth, the selector expression is illegal. For a value x of type I, where I is an interface type, x, f denotes the actual method with the name f of the dynamic value of x. If there is no method with name f in the method set of I, the selector expression is illegal. As an exception, if at type Evan. This is, let's see. Don't touch the line above. Okay, yeah. So this is passed in as a value, and then this is a reference. Get that. If m dot success increment. Okay, maybe I shouldn't assign it to a variable. What if I just use them? You know? Message failed. Message succeeded. Okay. I see now. Okay, I see what I did. I accessed a value and then I copied it into a variable and I incremented that. Like this is getting it actually. Like getting it actually and making it. So I should have just stupid. You see how pointers are confusing. I see. Alright, pointer quiz. What is the value of pointer y after the code executes? Okay. So y is a pointer that points to that. Value of y. Well, it should be 100, right? Pretty sure. Right? Let's double check. Wait, let me do import fmt 5 print print ln or right, I just want to dereference it. Yeah, should be 100. What is the value of x? Should be also 100 as well, because I also changed its value. Right, if I do the same thing. Oops. If I do x, it should be the same value now. And nil pointers can be very dangerous. If a pointer points to nothing, the zero value of the pointer type, then dereferencing it will cause a runtime error, a pattern that crashes the program. Generally speaking, whenever you're dealing with pointers, you should check if it's null before trying to dereference it. Okay. Gotcha. What am I changing? Hold on, let me do this. So let's take a look at our profanity checker. Oh, I see what they did. Let's make our profanity checker safe. Update the remove profanity function. If the message is nil, return early to avoid a panic. If message is null, okay. If message equals nil, return early. Go test -v. Bueno. Pointer receivers. Receiver type on a method can be a pointer. What do you mean? Oh, the type. Okay. Yeah. Methods with pointer receivers can modify the value to which the receiver points. Since methods can often need to modify their receiver, pointer receivers are more common than value receivers. When method with pointer receivers can modify the value to which the receiver points to. Since methods often need to modify the receiver, pointer receivers are more common than value receivers. Okay. However, methods with pointer receivers don't require that a pointer is used to call the method. However, methods with pointer receivers don't require that a pointer is used to call the method. The pointer will automatically derive from its value. Wait. So you initiate a car type struct, set the color to blue, and do c.color, which is blue. Blue. Okay. And what would be different here? Wait, so it didn't change it? Interesting. So it didn't change it because of why? Methods with pointer receiver can modify the value to which the receiver points. Since methods need often modify the receiver, pointer receivers are more common than value receivers. Methods with pointers don't require that a pointer is used to call the method. The pointer will automatically derive from the value. So this didn't do anything. I want an AI to explain this to me. Wait. Can they explain this to me? Why doesn't... Can you explain why they print differently? Whether the set color has a value receiver or a pointer receiver. So the first case is the value receiver. In this case, set color is defined with the value receiver of C car. Yep. This means C inside is copy of the original car object. When you call it, modifies the copy, not the original in main. Not the original C in main. Since the original C remains unchanged, so when you call C.setColor, it modifies the copy, not the original C in main. Oh, wow. Pointer receiver. So it uses the same, in this version, means that this means C inside the method is reference to the original car object. So that means the without the pointer receiver, it assumes it's the same. It assumes that it's a different object. So this is, think of it like this. When you pass a struct as a value receiver, Go copies that struct when calling that. Damn, that's a weird behavior. This means any modifications inside the method affect only the copy, not the original object. Since the method in the first case operates on this copy, the original C and main. Damn. It's interesting. I didn't even realize that. Okay. It's super important to keep track of. Pointer receivers are way more. Wait, so he said point. That's why. However, pointer receivers don't require. Pointer receivers are more common than values. Yeah, that's true. However, methods with pointer receivers don't require that a pointer is used to call the method. The point. Yeah, okay. Wait, do I need to do? Oh, yeah. Let's do it here. Put this here. But the pointer receivers don't require a pointer used to call the method. The pointer receiver will automatically be derived from the value. Don't require that a pointer is used to call the method. The pointer will derive that by, okay. Okay, so this is saying this is the same object. Notice C is not a pointer in the calling function, but the method still gains access to a pointer to C. Damn, that's really weird. Fix the bug in set message so that set message sets the message field of this given email structure and the new value persists outside the scope of the set message method. Oops. we're just saying we want this to be essentially pointer receiver, right? Oh wow, it's very good to know. Yeah, this is probably my favorite lesson because I actually learned a bit how Go does it. Pointers don't pass wait. Here, pointers don't pass copies. Here, new Go developers here, pointers don't pass copies, and take that to a logical extreme, concluding pointers are always faster because copying is slow. Ooh, okay, I kind of just said that earlier. No, bad stop. Here, my first one. Worry about writing clear, correct, maintainable code. If you have a performance problem, fix it. When thinking about using pointers to optimize code, use pointers when you need a shared reference to a value. Otherwise, just use values. If you do have a performance problem, consider stack versus heap, then copy. Interestingly, okay, I did learn it like that in my university. Like in the case was creating like having this really long string of numbers, and copying that again was like redundant, right? So that was it. But I get it. I get this point though. Don't make just because it does like just because pointers are fast because copying is slow. Always never don't do that. Don't think like that. That's a good point. Okay. Local non-pointer variables are generally faster to pass around than pointers because they're stored on the stack, which is faster to access than the heap. Even though copying is involved, the stack is so fast that it's no big deal. Once the value becomes large enough, the copying is that was my main point. So once the value becomes large enough that copying is a greater problem, it can be worth using pointers over. Yeah, that was kind of my case, so it makes sense in my scope. But that was a good point to keep in mind. One of the reasons Go tends to manage the Java machine is Go tends to allocate more on the stack. Okay. Where are Go values which pointers point to usually store? I think it's heap, right? Which is typically more performant to passive function. Probably a value for small data, but for larger data, then probably makes more sense. All right, last one here. Let's get it. Let's get it. I'm very much enjoying this Go course. This is a very fun one. Don't touch above this line. Okay. All right. Implementation. What do I need to implement? Implement an update balance function. It should take a customer and a pointer. Customer pointer. Okay, let's do that. So func update balance, and it should take a customer pointer. Let's call it C. And a transaction. T for transaction. Is that a pointer as well? Should take a customer pointer and a transaction and return an error. So I believe transaction is not a pointer. And it should, wait, what? It should return an error. Return an error. So let's, error. All right. Depending on the transaction type, it should either add or subtract the money from the customer's balance. If the customer does not have enough money, it should return the insufficient funds. If the transaction type isn't a withdrawal or deposit, it should If the transaction type isn't a withdrawal or deposit, it's return unknown transaction type. Okay. All right. If transaction type equals let's do deposit. Yep. Then we should do something. So this is saying T dot, right? And then we do 2 more times. No, the last case is we just return no. Return errors dot new invalid unknown. Okay. Unknown transaction type. And then return new if it's positive, right? Transaction. Let's do transaction. So deposit and transaction withdrawal. Transaction type. If it's that, what do I do? If it's a deposit, I have to add money. We do C.balance. So C.balance plus equals the T.amount. Same thing, but it's a withdrawal, so we Gucci. Depending on the transaction, if the customer doesn't have money, it should return. Okay, for this case, oh, I hate the nested loop. Let's do this case. If C.balance we'll just guard it actually. If it's a withdrawal and they have enough money and T dot, damn it, this is really annoying. Golly. It should return the unknown transaction type. I'll just do it nested. I hate this design, like, thing, but I can't think of anything else. C.balance is greater than less than C.balance is less than T.amount, then new errors at return errors dot new sufficient funds. Alright, let's just try that out. Nice. Next lesson, we're gonna learn about packages. Very big lesson on that. Packages, channels. I've never heard of channels. Okay, this is really important because I actually want to know some concurrency. I heard Go's concurrency is a very favorited feature. So I think up to this point, I'm probably like really new. I don't know much about these like topics here. But packages and modules tomorrow. So yeah, thanks for tuning in. Stay tuned for day 22 tomorrow. Almost a month. We're almost there. But yeah, thanks for watching. I'll see you for tomorrow's.